Hey, we're going to take a look at how to generate some toolpaths in Fusion 360. This is a sign that one of my friends wants to make, and the this is about a 15-inch wide by 60-inch tall, and it's going to be cut on a CNC router that'll do a 48 by 96 sheet. So if you look up here in the corner, this is the Z-axis. This is going up. X is to the right and Y is up, up, and then the Z is coming at me. The So originally this wasn't oriented this way, and I had to orient it this way to match the way that the machine lays. The machine does 48 wide by 96 long. Since this is more than 48 tall, we had to orient that to the y-axis. That just makes everything a lot simpler. Alright, so we're going to go over here to the design screen and go to manufacturing. We're going to be doing a 2D profile. Actually, the first thing we need to do is a setup. It's a new setup. We're going to tell it that first off we're going to put that XY origin right down here in the corner and on the top. On the top of the board. Then we're going to go in here and tell this that our stock is a fixed size. The stock width is going to be 48 inches. We're going to assume this is going to be cut out of a 48 by 96, and this is going to be 96 inches. This is going to be offset from the left side 1 inch, and it's going to be offset from the front side 1 inch. So it's going to cut it right down in the corner of the board. The Okay, I don't really know what size material this is, so that's something that I need to know. I'm going to assume that it's 3/4 inch, so I may have to come back and change that later. Well, actually, let's go back to design and see what it's designed at. So it's 3/4 inch, so that was a good guess. Alright, so we're going to go back into manufacturing, and we are going to we're going to pick a 2D profile, a 2D contour. Actually, we're going to do this a little different. This is going to be, we're going to start with a 2D pocket, because I want to cut out the bottom areas of these. So the first thing we need to do is select a tool, and we're going to use a 1/4 inch end mill. This is actually going to be a 1/4 inch upcut cutter. And we're going to go in here and change these parameters to 18,000 RPM. Cutting rate, we're going to run it at 70. going to ramp a little slower, so we'll go half, and plunge will go half. Okay, that's going to take care of the tooling RPM, and let's change this RPM to 18,000 as well. Alright, so now we're going to go to the geometry, and we're going to select the areas. Yeah, something's wrong. Tell you what, I'm just going to do one small area here. So this is cutting a 1/4 inch deep. I'm going to do that in 2 passes. And I'm going to leave a little bit of material. So I'm going to change this to 0.1 11. So it's going to do 220. It'll go back on and do a 30 thousandths cleanup cut. I'm not going to leave any stock. And we're going to do conventional milling. All that's good, so let's see what this does. So there's our tool paths. We can see some areas, like right in here, it's not going to cut anything. The reason it's not is because those spaces are too small. So we have a couple options there. We can go back with a smaller end mill. But let's just take a look at what this does. I want to speed this up. So that's what it looks like. I'm going to go in here and edit this and change something. I'm going to select a different tool. Pick an 1/8 inch tool. 20,000 RPM. I'm going to slow this down a little bit because the loading on it's going to be higher. Because of the aspect ratio, you're going to have a thinner cut. 30, 30. So we're also going to go in and change the multiple depths. We're going to do a 120. Well, we're going to do half of that, so we'll do an 0.06, 60 thousandths. It's going to take. This is going to take considerably more time, but just to show how it does. So now you can see that a lot of these areas that it didn't cut before, it's going to cut. There still are, let's see, this area right in here, it's still not going to cut that. We'd have to get somewhere around a 32nd inch, 1/32nd diameter cutter to do that. This one area here, let's see, it should tell me. This is an hour and 30 minutes to do this one little piece. So that's the downfall of using a smaller bit. Let's do a simulation. Alright, so we're going to go ahead and we're going to go back and change this back to the 1/4 inch, just so that we can see the comparison. We're going to go back 20, 70, 70, 70, 35, and 35. We're going to go back to the multiple depths, change that back to 0.11. And let's go into simulate and see the difference. It's 24 minutes, so it's a third of the time to do this part. Now there's a problem with this. In a lot of cases you can come back with a smaller tool and do some of the areas that it would miss, but that's going to have the problem is it's going to go over the same area if we cut it the same way. So this time we're going to do a 2D contour, and we're going to go in with that 1/8 inch tool and try to pick up the areas that didn't get taken care of with the 1/4 inch. Let's go back and change the multiple depth to 0.06, again about half the diameter, with a little less so that it with just a little bit less so that it has a smaller cleanup cut. So there's a lot of details that we're not going over here, but there's just an awful lot to it. And for now, I just want to get you through the process to see how it works. Oh, forgot to select a contour. So what I want to do now is I'm going to go down here and select these inside and outside profiles. So all it's going to do is just do the perimeters. Now this would be fine in a lot of cases, but in some of these it's going to leave some slots because the some of these gaps are just too small. So we've got everything. Looks like everything is the perimeter is done. So let's take a look and see what that generates. Alright, so you can see we got that perimeter and we've got the 2D pocket. So let's see what happens if we put those together, do a simulate, and we'll see what's left. So we actually did pretty good with that. Not sure what that is. I don't see any islands that were left, which was going to be my concern, but there is a little something going on here. So that might actually turn out all right. Let's turn off. Let's just check this and take a look. So there's enough of that to actually do it. So what you'll have to do when you run this is actually run each one of these. So we'll go up here and we'll generate. We'll post process. This is going to run on a Gerbil-based system. So we need to go to the installed post library, pull up Gerbil, and it's just going to be the Gerbil. Put a sign in, a comment here. This is called an FLL sign, and we're going to do a FLL P25 cutter. So I don't like to use decimal points in names because it gets confusing. So I use a P for a point. And let's generate the G code. I'm going to put it on my desktop in my G code folder. And I'm going to change this name to FLL P25 cutter. That's going to generate the code for the 1/4 inch tool. And there it is. Then we'll go down here and we'll post process it again. It's going to pull up the same one. We're going to change this to the P125. Change this name to FLL P125 cutter. And then we have the program to do that. So you'll run the P25 first and then the P125. You can carry all this same concept over to these other parts. Things like these sharp corners are going to make you want to use that 1/8 inch end mill again on the perimeter of those. You're going to have to use the 1/8 inch end mill exclusively in these small holes and these small openings. And here you're going to want to probably do the 1/4 inch for speed, and then the 1/8 inch to get sharper corners on those letters, because they're going to be rounded regardless, but you want to minimize that. So that goes into how you generate toolpaths to generate G-code and use a post processor to target that G-code to the specific machine you're going to use it on. So I hope that helps, and see you next time.